what we are having here, that we cannot join P and N to get PN junction. Okay, we cannot join P type and N type to get our PN junction. First of all, okay, means P type and N type. Okay, P type and N type. If you join, okay, then PN junction you will get. Then PN junction we will not get, because atomic separation not matched. Because atomic separation not matched. Okay, is ultimately what will happen, your separation will be huge. Separation between these P type and N type will be more, so it will not be equal to your atomic separation, will not be matched. Okay, this is the first thing. So what you have to do, one type you need to dope with P type. This is the junction. One type, okay, will dope with trivalent, so it will become P type. One side we will dope with pentavalent, so it will become your N type. Okay, one side we are going to dope with trivalent, one side we are going to dope with pentavalent, so it becomes your P type as well as N type. Okay, now here in P type, if I ask, we are having what? We were having your aluminum, if you remember. We were having aluminum. Aluminum was basically negatively charged. It was the negatively charged aluminum we were having. Okay, and this was the aluminum here, negatively charged. Okay. And we are having your in this one we can say L, Al, Al, and Al. Okay, lot of. And we are having your electrons as well as holes also. Means here we can say we are having our electrons and holes. Means in this one here, this is our okay, some electrons. Majority is the holes here. Okay, we are having huge number of holes in this. Huge holes are there. Huge number of holes. Okay, this side here. This N side we can say we were having your phosphorus. So this side we are having our phosphorus, but this phosphorus is, we can say, positively charged. And with these phosphorus, what we are having here? We are having our electrons as the major, and some holes are also present here. Some holes are present? Yes. Why some holes are present? Because holes are the minor here. Means here we are having our electrons. Majority we are having electrons, but some holes are also present here. Okay, some holes are present. Clear? Now, so here P is positive, and this okay, aluminum is negative. Why aluminum is negative? Because I have told you aluminum is the acceptor, and in P type, three things are there. Generally, people remember only two things. First thing is what? Major, minor, and immobile ions. You have to remember this thing. Immobile ions. Immobile ions. Okay, immobile ions in P type it is the negative, and in N type it is the positive. Okay, clear? Now near to the junction, what happens? They will diffuse. Okay, so electron hole diffuse towards each other, towards each other, and recombine. So diffusion current is obtained in circuit. Okay, diffusion current is obtained in circuit, means we can say here, okay, diffusion current is basically electrons are going this side, holes are going this side. Okay, so diffusion current, because of holes you can say current will be this side, so this is the IH. Because of electrons, current will be opposite to that, so this will be your IE. So if I ask what is the total current, then total current we can say the IE plus IH. Okay, total current will be IE plus IH. Any problem here? This is the your diffusion current, I diffusion. Okay, I diffusion. Okay, now what happens? Electron and hole recombine near the junction. Okay, and if they recombine near the junction, so what happens? Near the junction, only you know that near to the junction here in this region, what we only left? This side positive phosphorus, this side negative aluminum will be left out. Okay. This side we having positive phosphorus, this side we having your negative aluminum will be left out. Now, this side we having positive charge, here we can say positive charge, this side we having negative charge, and when you having positive charge and negative charge, internal field is developed, and direction of internal field we can say it will be always positive to negative. So this is known as your internal field. So positive and negative mobile ions are left. So E internal is developed, internal field is developed, and this developed internal field is in which direction? Your N2P, because field is always, direction of field is always positive to negative. Here we are having positive are left, here only negative are left. This region is known as your depletion layer or depletion region. Okay. Now, if they are asking what is the direction of diffusion current, then we know direction of diffusion current is what? You can easily say direction of diffusion current is from, yes, can you tell me? It is your P to N. Okay. Direction of diffusion current is P to N. Okay. P to N. Are getting this thing that what is the direction of diffusion current? Yes. Okay. Okay, good. Now, listen, this internal field, okay, this electron was going this side, okay, this hole was going this side, and this side your one internal field is developed, okay. You know, this side we got this internal field here. Now, this internal field will allow to meet or will not allow to meet. This electron hole want to recombine, okay, they want to meet and they want to recombine. Now, this will allow or will not allow? This electron was going this side, so current was opposite side here in this direction. Hole was going this side, so current was, so direction of diffusion current was, total direction was in this side, okay, in this direction. So that is the your P to N. Force on hole, it will, okay, it will apply force on hole in direction of field, it will apply this side. On electron, it will apply this side. So now it will not allow, okay, it will apply, it will try to separate. It will try to separate, means this internal field is just acting like your guard at the boundary. You see, this is the boys campus, this is the girls campus, it is the boundary, okay. So what it will do, if you go near to the boundary, then it will try to separate, okay. Same thing here also in this one, it will apply force on this hole and electron, so they cannot separate, means diffusion, this will be acting like barrier, okay. Due to this, electric field is developed, okay. So, okay, internal field is developed from N to P. So, a potential barrier is formed. A potential barrier is formed. Okay, a potential barrier is formed, and potential drop is known as potential barrier. This potential drop is basically known as potential barrier. Is this side you will be having a high potential, this side we are having low potential. So this is known as your potential barrier. Clear? Now, this internal field is going to oppose diffusion or will support diffusion. This will oppose diffusion. Okay, this internal field E internal opposes further diffusion. It will oppose further diffusion. So diffusion current decreases. Okay, diffusion current decreases. Why potential drop? Because you know this side positive means high potential, this side negative is low potential. Okay, that's why drop is there. Means if I want to draw graph for this, okay, I hope you have written this one. Okay, so in this one, if I want to plot graph here, okay, you can see in this one that here this is this is our depletion layer, dot. Okay, here this side we are having your positive here. Positive is your high potential. Okay, so if you draw here that this side we are having high potential, positive side, and here this is your negative side. Positive side, this is the junction here. This side positive, this side negative. Positive and negative, so we can say this is our basically graph of This we can say this is the graph of V and R. Okay, V and R, and this height, okay, here to here, this is basically known as your potential barrier. Okay, we can say this PD is basically known as potential barrier. This potential barrier for silicon, this is means we can write here for silicon this potential barrier V silicon is 0.7 volt, and for germanium this is 0.3 volt. Okay, this much barrier will be there. Okay, this much barrier is there. Means if you want to cross, then you need this much energy to cross, otherwise you will not be able to cross. Okay, so lot of electron and holes don't have energy, so they cannot reach or they cannot meet. Okay, and when they are not able to meet, okay, then ultimately what happens? Diffusion current will be reduced. Okay, now can we go for next? So this is the graph of barrier. You have to remember here in this one, graph of barrier. Okay, this side, which side is high potential? You know, N side is high, because N side is your positive charge, and here it is the negative charge. This is the graph of potential barrier. Okay, now next thing in this one is in this region here, in the depletion region, if any carrier is present, okay, suppose because of temperature, you know, electron hole can be generated also, and if electron holes are generated, then what this field will do? What this field will do? If electron holes are generated, then what this field will do? It will try to meet, means it will allow meeting, or it will try to separate. What it will do? Yes, try to separate. Okay, it will try to separate. Means if any electron or hole is created here, suppose this electron, okay, I can take this blue or green better. If this electron and hole is created here, then this electron, it will try to separate, it will try to send this side, hole it will try to send this side. Okay, electron it will say that go this side, hole it will say this side. Or we can say that here this hole is there, means with this hole these some electrons are there, this electron here, and this side with these electrons some hole is there. Okay, so what it will say, that electron must be one side, hole must be one side. Means this electron is your, okay, this electron is minority here. What it will say to this minority, that you go your side. What it will say to this hole is the your minority here but majority here. It will say to this hole, you go your side. But they will be going because they are happy here. They are happy here. Okay, they are also happy here. It will try to send forcefully. They will not be going. So in this case, they will be going very, very slowly. So we can say this is the your drift current. What it will say, that it will be saying to this electron here, to this electron, okay, that go this side. To hole, it will say go this side. So when hole is going this side, we can say forcefully it will send hole going this side forcefully, and electron basically going this side. So we can say IH will be basically this, IE will be basically this. So total current we can say it is the I as our drift current. So if anyone is asking what is the drift current, then drift current is that if any, this is because of your minority, we can say. Okay, minority. So if any carrier is present, then it will try to separate. Okay, IE plus IS. If I ask what is the direction of drift current, N to P or P to N, it is your N to P. Diffusion was P to N. Drift is basically what? Drift is your N to P. Okay, so two types of currents are there. Okay, two types of currents are there. One is the drift, one is the diffusion, and at equilibrium both are same. If they're asking, and then at equilibrium both current are same. So is there any net current? Means we can say at equilibrium, where I can write in the next slide. Have you written this thing? Okay, means we can write here in this one at equilibrium. So at equilibrium, your I drift is basically equal to I diffusion. So I net becomes what? I net is 0. Okay, I net is 0 at equilibrium. There is no net current. Okay, because drift and diffusion are same. Now drift is because of, this is the drift and this is the diffusion. Okay, drift is because of minority, and this is because of, we can say, majority. Which current we can change, drift or diffusion? Which we can change? You know, drift we cannot change because number of minority is fixed. Diffusion you can change because diffusion was reduced. Diffusion you can allow. Okay, so diffusion can be increased. Okay, so in drift there will be any major change? Any major change in drift? In drift there is no major change. In which we can we can do major change? We can do major change in diffusion. Okay, diffusion, because there are the huge carriers, either you can allow or you will not allow. Okay, you will allow or you will not allow. This is the thing here. Okay, now we having our biasing of diode. Next thing, biasing of diode. What is the meaning of biasing of diode? This is the meaning. Okay, application of battery. Biasing means your application of battery, means we will be applying now battery, application of battery. Whatever things I have explained till now, there was the unbiased. I didn't use any battery. Okay, in this case if you see, I have not used any battery here. Okay, I didn't use any battery here in this one. Okay, so if no battery is there, then we know your net current is how much? Net current is 0. Okay, if there is no battery, then net current is 0. Okay, now I will use the battery. So one condition will be the forward bias, one will be the your reverse biased. Okay, one is the forward biased, one is the reverse biased, and one is the your unbiased. Okay, one is the unbiased. Unbiased means no battery. So no battery means I is 0. Okay, and forward bias and reverse bias we will see. Okay, clear? Now here I am going to write this side your FB, forward bias condition. This side I will be writing your RB, reverse bias condition. Okay, forward as well as reverse. Now listen, no, in atoms not required. Okay, atoms you can do by yourself also. You choose semiconductors, we are doing semiconductor. If time is left in 15 minutes, I will tell important points of atoms. Okay, atoms is the simple thing. Now in forward bias, basically we do like this. This is our okay junction here in this one. This is our P side, this is the N side. We connect P side with positive, so P becomes positive side, this becomes your negative side. Okay, our representational diagram is like this. This is the P, this is the N. Okay, this line is the N here, and we can connect our battery like this. This is the forward biased. What is the meaning of forward biased? Means when P is connected with positive. Okay, and if we connect like this, okay, like here, this is the P, this is the N. If we reverse the battery like this here, okay, then you can say now here N becomes positive and P becomes negative. So things are reversed. You can say here, if P is positive, N is negative, then it is the forward. Okay, if you reverse, then P negative and positive is the reverse bias. Okay, and here we can say in this one, its representational diagram is like this. Okay, so can you easily identify which is the forward bias and reverse biased? Is if N becomes positive, P negative, then it is the reverse. If P is positive and negative, then it is the forward biased. You know, internal field is, direction of internal field was here. This was the internal field. Here also we can say internal field was in this direction. But when you are applying this, okay, external battery, here positive, here negative, so we got external field. External field here, and here we can say external field positive to negative. Field is always positive to negative. This is the external field. Can you tell me here in this one, number one, here E net is decreased or increased in the forward biased? E net is decreased or increased? Tell fast. E net is this is internal this side, external this side. Both are opposite to each other. If both are opposite to each other, that means it is decreased. Okay, here decreased. If internal field is decreased, so if I say barrier potential, What about barrier potential? What about barrier potential V? V is also decreased. Our barrier height will be decreased. V will be decreased means we can say our barrier height or barrier potential will be decreased. Okay, it will be decreased. Here we can say number one in this one, your E net. Both are in the same direction. So here and here we can say your barrier will be more. Okay. Now here barrier is less. Here barrier is more. If barrier is less, it will allow current or will not allow current? Can you tell me? It will allow or will not allow? Means here this field was opposing. Okay, this field was opposing because of field they were not able to meet. They were okay. Diffusion was reduced because of this. Because of this field, it was reduced. Now strength of this field is reduced. Means your that guard was not allowing you to meet. Now strength of that guard we have reduced. So what will happen? It will allow me which current will increase? Okay, diffusion current increases here. Okay, in this one we can say it will allow current. Which current increases? I diffusion increases in this. Okay, because ultimately it will allow majority, so diffusion is increased. Clear? Diffusion current increases. Now, so if it allow current, okay, diffusion current increases. So can you tell me here resistance? It offers very less resistance or high? We can say it offers very low resistance. It offers very low resistance. Okay, means does not allow current. Okay, does not allow current means in this one I diffusion will be basically I diffusion will be decreased. Diffusion will be decreased. Okay, no major impact. No major impact on drift. Why no major impact on drift? Because drift is because of minority. Okay, drift is because of minority, so no major impact on drift up to some specific voltage, up to some voltage. What is voltage? I will tell. Okay, no major impact on drift because drift is because of minority. Someone is asking, sir, what is the barrier height? Barrier height is this. This height is basically known as barrier height. Okay, this height we can say barrier potential or barrier height. Okay, this is the barrier height. Now here we can write it will not allow current means offers very high resistance. Offers very high resistance. Okay, offers very high resistance. Clear? Number 5 we can say this one. Okay, means offers very high resistance. So for ideal diode, how much resistance? Ideal diode we can say resistance means very high. Very high means how much? Infinite resistance means ultimately current will not flow in reverse. In a reverse bias, current will flow. In case of ideal diode, current will not flow. In case of our real diode, some current might be there because of your drift. But here we can say current is almost zero. Okay, current is almost zero in reverse, and in forward bias, it will allow the current. So if you want current to flow in one particular direction, if you want to flow current in unidirectional in one particular direction, which one you will use, forward or you will use reverse? Will use forward. Okay, if you want current to flow in one particular direction, we are going to use our forward biasing. Okay, now here we can write in this one number 4. Means okay, it was the number 3 here. Number 4, width of depletion layer. Width of depletion layer. Okay, basically this is known as your width of depletion layer. This is D. Okay, this is the depletion layer, and this width is known as your width of depletion layer. Okay, here also I will ask width of depletion layer. Width of depletion layer. What do you say about the width of depletion layer? In forward biased, what will happen? In forward bias, width of depletion layer will be okay decreased. And here width of depletion layer is increased. Okay, what is the reason for this? Listen. Now, reason is because in this okay forward biased, okay, here in forward bias it will allow, okay, so when it will allow, so your electron and holes will come closer to you, okay, it will allow from this side also hole will come, from this side electrons will come, so they are coming closer to us, so this width will be less. In reverse biased, what this field will do, it will not allow, so this will push electron this side, this will push this hole this side, so ultimately width will be more. Means if it allows meeting, then what happens? Suppose it allows meeting, then from this side holes will come, from this side electrons will come, so width will be somewhat less. Okay, and if does not allow, then it will push this side, and pushing both sides, so ultimately width will be more. Okay, so we can say in reverse biased width is more, and in forward biased width is less. Okay, clear these points? Yes, anyone having any problem in this one, ask fast, because now I have to tell some numericals also. Done? Done? Okay, now when forward bias is there, okay, if forward bias circuit is there, then you have to replace with plain wire. If this is the ideal diode, okay, ideal diode, okay, then you have to just, okay, if this is like this, okay, then you can simply write like this, okay, simply write like this, okay. If reverse bias is there, okay, if this is the reverse bias, and okay, like this, you know, this is the reverse bias circuit, okay, and if this is the circuit like this, then what you will do in reverse bias, any current will be there or no current? There will not be any current in this, and if there is no current in this, then you have to just do like this, okay, circuit will be removed. Okay, so any current here, here we can say there is no current, okay, it will be removed, circuit will be removed. Okay, and here we can connect, okay, ideal diode, like I can say 5 volt, this is the 1 kilo ohm, so we can easily find 5 volt and 1 kilo ohm, so here current will be equal to how much? 5 by 1 into 10 power 3, and it becomes your how much? 5 into 10 power 3 ampere. Okay, or we can say milliampere. Okay, so here you have to just cut the circuit, you have to remove that circuit, and here you have to just replace with plain wire if it's the ideal diode. Okay, for silicon you will be taking 0.7 drop will be there in silicon, 0.7 loss will be there. In germanium, how much loss will be there?